Hello friends, this video on algebraic expressions part 7 is brought to you by examfear.com. No more fear from exam. So now that we got a fair idea about algebraic expression, now the next question that might bother you is how do we perform different operations on algebraic expression? For example, if you are given two expressions, 5x and 3y square. Now if I ask you to add these two, so how will you add them? Now, sounds difficult and complicated as well. So if I give you any two expressions, now these expressions could be a monomial, binomial or polynomial, whatever. So how will you perform addition or subtraction of algebraic expressions? Now the next question that might strike your mind is, can we do addition and subtraction on expressions as simply as we do them on numbers? Like 5 plus 3 is very easy to add, but can we add 5x plus 3y square that easily? Or can we add or subtract any two expressions, or there are some conditions that only certain types of expressions can be added together and certain kinds cannot be added together? So let us learn in detail about the addition and subtraction of algebraic expressions. Let us first talk about addition of algebraic expressions. Now, there are certain steps that we follow to add algebraic expressions. First of all, rearrange the terms. Now, why do we rearrange terms? Because we want to collect the like terms together. So, let me take example. So, first we will take a very simple example. So, let's say you are given two terms, 5x and 8x, and you have to add these two. So now here, this is simple because you just have two terms which you need to add, and both these terms are like terms, right? Because both of them have same algebraic factor which is x. So they are already like terms. So you really do not need to rearrange terms. Fine. Now add the like terms. How do we add like terms? Numerical coefficient of the result is equal to sum of numerical coefficients of the terms. So in this case, what is the numerical coefficient of the sum? So the numerical coefficient of this term is 5, numerical coefficient of this term is 8. So you add the numerical coefficient, that is 5 plus 8. You add the numerical coefficient and leave the algebraic coefficient as it is. So 8 plus 5 is 13. So the sum of 5x and 8x is 13x. So that is how we add like terms. Now let me take another example and we will try to add these following the same steps. So let's say that you have to add 3y square with 1 by 2y square. So in this case, are these two terms like terms? Yes, they are like because both of them have same algebraic factor, that is y square. So again, we can follow the same technique. Add the numeric coefficients of the two terms. So 3 plus 1 by 2 y square. So 3 plus 1 by 2 is 7 by 2. So the result would be 7 by 2 y square. So we will take one more example. So let's say in the third example, we say you have to add y square plus 1. This is one algebraic expression and the other algebraic expression is x plus 1. So you have to add these two algebraic expressions. Now till now in example 1 and 2, each algebraic expression was a monomial. In this case, each of them is a binomial. So we are basically adding two binomials. So this means y square plus 1 plus x plus 1. So in this case, all the terms are not like terms. So the need of rearrangement starts, right? So we need to rearrange them. So let us try to rearrange all the terms with algebraic factor y square together. So how many terms do you have with algebraic factor y square? Only one term, that is y square. Now let us collect all the terms together with algebraic factor x. For that also we have just one term which is x. Now let's collect all the terms with no algebraic factor, that is basically the constant terms together. So how many constant terms you have? 2, that is 1 and 1. So let us put these two together. Now we can always add the like terms. We can only add the like terms. So what will happen? 1 plus 1 is 2. So y square plus x plus 2 is the sum of these two algebraic expressions. Now you might ask that how can we add y square plus x? We cannot add them. So we can only add the like terms in an expression. We cannot add the unlike terms together. So the result of these, sum of these two algebraic expressions or the result of the sum of these two binomials would be another trinomial. Okay, so if this concept is clear, let's take one more complex example. Let's say you are given one expression as y square plus 1 and the other expression is 3y square plus y plus 2, and you have to add these two. So how will you add them? So y square plus 1 plus 3y square plus y plus 2. So let us start arranging the like terms. So y square and 3y square, these are like terms because both of them have same algebraic factor, that is y square. So we put them together. Now how many terms do you have with algebraic factor y? Only one term. So we put it together. How about the constant terms? There are two constant terms, 1 and 2. So we put them together. So now y square plus 3y square. So what would be the sum? So for y square, the numerical coefficient is 1. So 1 plus 3, that is 4y square. So this becomes 4y square plus y plus 3. So 4y square plus y plus 3 would be the sum of these two algebraic expressions. So the concept is pretty simple. It is just that you need to arrange the like terms together because you can only add the like terms together. Okay, so now let us do some exercise on adding algebraic expressions, because in the previous slide we took mostly simple examples. So let's say that you are given these three algebraic expressions and you have to add them. T minus 8tz, 3tz minus z and z minus t. Now in the previous slide we took simple monomials and binomials, so it was pretty simple to collect the terms together. But when you have bigger algebraic expressions, then the work of rearranging the terms sometimes becomes tedious and complex. So to avoid that, what we do is there is a better way of adding the expressions. So let's look at this way. So you write down the first expression, 8 minus t minus 8tz. So we wrote it. Perfect. Now when the turn for the second expression comes, instead of writing it beside this expression, write the second expression below the first expression such that all the like terms are written just below each other. That means in the second expression you have 3tz. So 3tz is like term with 8tz. So let's write 3tz just below 8tz. So 3tz has a plus sign before. Right? Okay. And what is the other term here? The other term is z. But in the first expression, you do not have any term with z. So we will not write z below t because z and t, they are not like terms. So let us write z separately in a different column, in a new column altogether. Now let us move on to the third expression, which is z minus t. So where do you think you should put z? Below its like term. So z and z, they are like terms. So let's put z below z. So but this time z has a plus sign. And the next term is minus t. So where will we put minus t? Again with the like term. So minus t will be like with plus t. So we put minus t here. Right? So in this way we arranged these three algebraic expressions. Now what we do? So for the first algebraic expression we have two terms. In the place of the third term, it has nothing. So we can write it as 0. For the second expression, the first term, we have nothing. So let's write it as 0. Similarly, in case of the third algebraic expression, the middle term is nothing. So let's put it as 0. Perfect. Now let us add these three. So with this arrangement, there is no chance of making any mistake because you can see that the like terms have been put together or not. So now let's add these. So now when you add this, t minus t is what? Plus t minus t would be 0. Similarly, minus 8 plus 3tz. So obviously, the algebraic part will remain the same because they are like terms. Just focus on the numeric part. So it is minus 8 plus 3, which makes it minus 5. Again here minus z plus z is 0. So therefore, the sum of these three algebraic expressions would be minus 5 tz. So this would be the sum. Now let us try one more example so that we get familiar with this technique. So here again we have three different algebraic expressions and each algebraic expression has three terms. So let's start with the first one. So first one is a plus b minus 3. So we write it as it is. Next one is b minus a plus 3. So where will we write b? B is actually plus b, so we will write it below b. Minus a, we will write it below a, and plus 3, we will write it below minus 3. What about the third expression? It is a minus b plus 3. So a we will write below a, minus b again we will write it below plus b, and plus 3 we will definitely write below the 3's. So now we have all the a's together, all the b's together, and all the constant terms together. Let's add them. So in this case, a plus a. So two a's together will be 2a minus a. So overall it will become a. Similarly here, b plus b, that is 1b plus 1b will make it 2b minus 1b, that is again 1b, that is b. Here 3 plus 3 would be 6 minus 3, that is plus 3. So again you get plus 3. So when we perform these sums, so it again follows the same concept of BODMAS, that is whenever you have 2 plus, so you perform the addition first and then you perform the subtraction. For example here, b plus b. So you perform the addition first, which is 2b minus b. That makes it 1b. So in this fashion, in this case, the sum of the three algebraic expressions would be a plus b plus 3. Thank you. Please visit examfear.com for free quality education. You can learn with a simple 4-step learning process wherein you can watch video lessons, you can ask your questions, you can refer notes, and you can take a free online test. We have content for class 6 to 12 on physics, chemistry, mathematics, and biology along with practical videos. So please subscribe to our channel for daily updates. Thank you.